Hello friends, welcome to the Tech Protein. This is Ranjay, and in the last session we have seen the different classes of an IP address. Now let us try to understand how these class ranges are defined. Okay, so let me now wipe out this section. So let us put the range of IP addresses there. Let me clean it properly so that you can see it better. So friends, now in the last session we have seen different classes of an IP address. Okay, so class A was the first class that we discussed, then class B, class C address, class D address, and class E address. So now if you have to remember the ranges, you can simply remember it like 1, 2. So let us put the calculated values, so 0 to 127. Of course, now you know that. So these are theoretical values, but practically it only 1 to 126 addresses can be used, right? So in the same way for class B, it is 128 to 191. Class C is 192 to 223. Class D range is 224 to 239. Sorry, it is 239, and then 240 to 255. So friends, now it is very clear to you that the range for class A is 0 to 127, but why this range only? Okay, so to understand this particular concept in a better way, you need to understand the concept of priority bit. Okay, so it is, friends, one thing I would like to tell you here is that ranges are defined. There is some purpose behind these ranges. If somebody says that I want to use IPv4, right? We are specifically talking about IP version 4. Okay, version 4. So there has to be some logic that this network is going to work in this particular fashion, right? This is the range. If I put this number in the IP address, so this is how computer is going to identify the type of network, right? Or the subnet mask, right? Consider if you simply enter an IP address 192.168.10.10 in your computer and press tab button, okay, it is automatically going to, give the subnet mask value as 255.255.255.0. okay, or if you simply delete this subnet mask and put an IP address here as 172.16.27.1 and then again press tab, it's going to give you a subnet mask of 255.255.0.0. okay, so usually you can just try this on your computer by removing the subnet mask, enter an IP address starting with this IP or 192 and see what it shows in the subnet mask when you hit the tab button on your keyboard. So friends, if you enter an IP starting with 192, it's going to give you 255, 255, 255. So 255 will be mentioned 3 times. Here I have used an address 172. It is now showing 255.255.0.0. If I consider an address like this, consider I put an address 10.10.10.10. The subnet mask value is going to reflect like this: 255.0.0.0. So if you enter an IP address, computer will automatically give you a subnet mask in the next field of the IP address. So how computer is understanding is because there is some logic behind this IP address, and that logic is the first field, as we have discussed in the earlier session. And we know that the class, if I put a value between 0 to 127 in the first field, then it's going to consider it as a class A address and put the subnet mask of class A only. Okay, so just to create some logic, priority bits were defined. So what was the logic? So let us try to understand. So consider I have an IP address something dot something dot something dot something. So this is the 4-field address, and now you know that the first field is divided into 8 bits. Okay, so this first field, if you try convert that into binary, it comes out to be 8 bits: 1 2 3 4 5 6 7 8. So there are 8 bits which represent the decimal value in the first field of the IP address. So in the last session we have also understood that the value can be the lowest value could be 0, all zeros. So this is the binary conversion of decimal 0, and at the max, say consider you want 1, so it would be 0 0 0 0 0 0 0 1 to the base 2, right? If you want 5, let me take a random value. So 5, so it is 1 2 4 8 16 32 64 and 128, right? I want to achieve decimal 5. So how can I get this? I'll have to add 4 and 1. So let me make value of 4 as 1. Again, the last bit has 1. 2, I'll make it 0, and rest all the bits are going to be set to 0. Now if you look at this particular IP, it is 5. So binary conversion of 5. So at the max, what I can do is I can convert all the zeros into ones. So this is coming out to be 255, as we discussed in the last session. So the lowest value in the first field of this address is going to be lowest. If I calculate, it is going to be 0, and highest number or the largest number could be 255. Again, if it is class, if you look at the practical implementation of this, again you can only specify number between 1 to 123 in the first field of IP address, okay, to be more practical on this front. So friends, now you have understood that the first field denotes the class. Each field is of 8 bits. So this is again of 8 bits, 8 bits, 8 bits, 8 bits. So I have shown 8 bits here, and now you have a clarity on how these bits are translated, from decimal to binary or binary to decimal. Now the point is, how do we arrive at this particular range, right? So these are the bit values, and priority bits help us define that value in the first field. So let us talk more about that now. So consider there is an IP address. We are only going to consider the first field when we talk about priority bits. So the rest fields I'm going to leave it as it is. Now let us consider the first field. and there are 1, 2, 3, 4, 5, 6, 7 and 8 bits. Okay, so now for class A, the priority bit value is defined as 0. So if I say priority bit value is defined, now let me write the ranges on the right side first so that you get a better clarity. So priority bits. So class A, the priority bit is defined as 0. For class B, the priority bit is defined as 10. Then for class C, it is 110. Class D, it is 1110. And for class E, it is 1111. So that is how the priority bits are defined. Now what is the significance? Okay, so consider I say I have an IP address, the first field, and this is of 8 bits. If I say class A has a priority bit of 0, it means this number is not going to change throughout the range. Okay, so consider now if I have to make all these bits 0, this is decimal 0. Now this is going to be 0 throughout the field, so consider it is 0 throughout the range. If I want to increment the value by 1, it is decimal 1. Now I want 3. So what I'll do 3, again you will have to build the logic 1, 2, 4, 8, 16, 32, 64 and 128, right? Now I want decimal 3, so 2 plus 1 is going to come out as binary 3. If I want 4, or say I want 7, so 4 plus 2 is 6, 6 plus 1 is 7. So this is going to be 0, 0, 0, again 0, 4 plus 1 plus 4 plus 2 plus 1. So this is the binary conversion of 7. Now if you go to the end of this range, you can turn all the other zeros into 1, but you cannot change the first bit, that is the priority bit for class A. So that is why we have set the priority bit for class A as 0. So friends, now if all of these bits become 1 except the last bit, then what you will have to do, you will have to add all these values. So if you add 64, 32, 16, 8, 4 to 1, this value, the theoretical value is going to be 127. Let us add 64, 32, 16, 8, 4, 2, 1. So 6 plus 4 plus 6, then 6 plus 6, 12, plus 8, 20, 24, 25, 26, 27, carries 2, 6 plus 2, 8, 9, 10, 11 and 12. So that is why the IP class A starts with a number 0 and class A range ends at 127. So I hope now you have a clear understanding why class A range is 0 to 127. So friends, I hope you understood. Now let us try to check if we can arrive to this value by assigning priority bit as 10 to class B IP address. So let me just wipe it off. Let us consider 8 bits again. So this now becomes class B. So 1, 2, 3, 4, 5, 6, 7, 8. So 8 bit values I have written here. Priority bit for class B is 10. So this is not going to be changed throughout the range. So 10, 10, and so on. 3, 4, 5, 6, 7, 8. So now the first address, now if you look at, has automatically become 128. So this is 1, 2, 4, 8, 16, 32, 64 and 128. So by setting up the priority bit as 10, the range starts with a value of 128. If you add 1, consider 0, 0, 0, 0, 0, I'll make this 1. So 128 plus 1, it is going to be 129. I add another value, say I add 4, so I'll make 4 as 1, rest as 0. So rest bits again set to 0, so 128 plus 4 is 132. So this becomes 132. At the last, what you can do is you can convert all these zeros into ones. 1, 2, 3, 4, 5, 6, 7, 8. So what will happen? You will need to now add these values except 64, because this is the priority bit 10 and this cannot be changed throughout the range for class B. So if you add now 128, let me add it here, 128, 64 I'll exclude, 32, 16, 8, 4, 2, 1, 8 plus 2, 10, plus 6, 16, 16 plus 8 is 24, 28, 29, 30, 31, carry 3, 3 plus 2, 5, plus 3, 8, plus 1, 9, and 1 as it is. So the last value of this particular class is going to be 191. So that's the reason, friends, the class B starts at 128 and the last value is 191. So if you look at this, the range for class B is 128 to 191. So I hope, friends, in the same way now you can consider for class C. So I'll just remove this. So similar way you can calculate the range for, now let me directly take class E. So class E, what is the priority bit? 1, 1, 1, 1. So it is going to be 1, 1, 1, 1. It's not going to change. So 1, 1, 1, 1, 0, 0, 0, 1, 1, 1, 1, 1, 0, 0, 0, 2. At the max, what will happen here? All zeros will become 1. So this is 128, 64, 32, 16. So if you add all these, so 128 plus 64 plus 32 plus 16, 12 plus 2, 14 plus 6, 20, carry 2, 4 plus 6, 10 plus 4, 14, it comes out to be 4, carry 1, so it's going to be 240. So it starts at 240, and if all becomes 1, you already know the value is 255. So for class E, the range is 240 to 255. So friends, I hope you understood how these ranges are calculated and what is the significance of the first field in the IP address and how you can identify the class of an IP address. So with this, we have understood some of the basics of IP addressing. So in the upcoming session, let us talk something more about the subnet mask. Okay, so I hope you have better clarity. If you have any questions, any doubts, you can write to me in using the comment section. Okay, so I hope this helps you understand concepts in a better way. Friends, I am just putting effort in these videos just for the sake of helping people understand all these basic concepts, because if you understand the basics, you can then develop further on top of your basic skills and then advance into your career, right? So one message I would like to say here is, if you look at the Eiffel Tower, okay, 60% of the metal of the Eiffel Tower itself is within its base, okay, and that is why it makes it stand so tall, like a multi-story building, right? So the reason for that is because the foundation is very strong. So if you want to advance in your career, your foundation needs to be very strong, so that then you can apply your skills, correlate things to understand, or troubleshoot the network in a better way. So I hope this was helpful. I am Dhananjay. And thank you for joining the training program, guys. Thank you so much.